Welcome to day 5. Tomorrow we've got a quiz, and then you also have homework, page 29 and 30. You have a warm-up. If you could pause the video, go through, do the warm-up. When you're done, it'll pop up for you to put in your answer. So go ahead and pause the video now. So start out by doing your slope. Slope is y2 minus y1 over x2 minus x1. So pick any y to start with. I'm going to start with the 9. 9 minus the other y, which is negative 7, over. If we started with 9, we got to start with negative 4 for the x's, minus the other x, which is 2. Minus a minus becomes a plus. So 9 plus 7 is 16. Negative 4 minus 2 will give us negative 6. This will reduce to negative 8/3. We want the perpendicular bisector, so we need the perpendicular slope. Our perpendicular slope, flip and negate your slope, so we get positive 3/8. We'll come back to that in a minute. We now need to find the midpoint. The midpoint, you average your x's, average your y's. So we'll have negative 4 plus 2 over 2. We'll have 9 plus a negative 7 over 2. Negative 4 plus 2 gives us negative 2. Divided by 2 is negative 1. 9 plus a negative 7 is 2. Divided by 2 gives you positive 1. Well, now we have our slope and we have our point. So we'll have y equals, oops, not negative, but positive, 3/8 x plus b. We'll fill in our x and our y. So 1 equals 3/8 times negative 1 plus b. So this is 1 equals negative 3/8 plus b. Add the 3/8 over. And that'll give us 11/8 is equal to b. So therefore our equation will be y equals 3/8 x plus 11/8. Moving over to the homework, we want the length of a leg in the right triangle. We had the hypotenuse was 8, the other leg, or the hypotenuse was 12, the other leg was 8. So do your Pythagorean theorem, make sure the 12 is by itself. When you subtract the 64 over and then take the square root, we'll do a menu number factor. You get 4 2's and a 5. So circle your pairs. 1, 2 from each pair goes out front. 2 times 2 is 4, so we get 4 square root of 5. We want to find the length, so that's the same as finding the distance. So just do your distance formula. X minus your x, parentheses squared, plus y minus your y, parentheses squared. Just be consistent in your order. Whichever x you use first, use its y first. We just wanted in decimal form here, so you can then just put that in the calculator, and you got choice 4. If we want to divide a segment into 2 congruent segments, that means we want to find the midpoint. So add your x's, divide by 2, you get 6. Add your y's, divide by 2, and you get negative 5. This one gave us the midpoint in one of the endpoints. We don't know the other one, so call the other endpoint xy. So we would add our x's, negative 2 and x, and divide by 2. Add your y's, 7 and y, and divide by 2. And we know that should equal 4, 3, which was the midpoint. Well, now we'll set up 2 equations with our parts. The 4 should give us negative 2 plus x over 2. Put the 4 over 1 and cross multiply and solve. You get x is 10. Do the same thing with the y. Take the 3 from your y, set it equal to 7 plus y over 2. Cross multiply and solve. You get y is equal to negative 1. So 10, negative 1 is our coordinates for D. So we're going to draw a horizontal line through our midpoint. So first find your midpoint. Add the x's, divide by 2, add the y's, divide by 2. So you could either have 13 halves, or you might have called that 6.5. And you either have 31 halves, or you might have called that 15.5. We want to draw a horizontal line that goes through that. So let's say that's our point there. A horizontal line is a y equals line. Horizontal lines are always y equals some number. Vertical lines are x equals some number. So we should either have either y equals 31 halves or y equals 15.5. And we're getting those because those are the y value of our point. Six is just like the warm-up. Do your slope, we get negative 1/4. Flip and negate it to get the perpendicular slope, you get 4 over 1, which is the same as 4. Do your midpoint, we get 1, 3. Then we'll take y equals 4x plus b. We'll put in our x and our y into the equation so we can solve for b, which is negative 1. And then we get 4x minus 1 for our equation of the perpendicular bisector. So a perpendicular bisector, if that's our original segment, we just found the segment that's going to cut it in half. Okay, going to go through the midpoint because we know segment bisector implies midpoint, and we'll cut it into two congruent segments because the midpoint implies two congruent segments. And 7, we wanted to know which one was further from A. So we got to do the distance for each of them. Now, it didn't say we had to specifically tell the distance, so we can make it a little easier and just put it in the calculator. So use A and B. I did my x from A minus my x from B, parentheses squared, plus my y from A minus my y from B, parentheses squared. And when you put that in the calculator, you get 10. Do a similar idea using points A and C, you get about 9.4. So therefore, point B is further away from A. All right, we're going to be starting on page 25 for our lesson for today, so if you could switch there. And we're going to be working with circles. So there's two important features of a circle that we'll always want to know. We will want to know the center and the radius of the circle. The radius is from the center to any point that is on the circle. It's that distance. The diameter would be all the way across the circle, and the diameter is twice the radius, or you could think of it as the radius is half the diameter. Your center we will often call h comma k. This is our general form, our center radius form of a circle. So take a moment to write that down in the gray box there. We will be using this form a lot. So let's say hypothetically, our center was 5, negative 2. And let's say our radius was equal to 3. Well, the center we said we usually call h and k. So that goes in the h and k spots in our equation. So we'll have x minus, and then our h value, which is 5 squared, plus we're going to have y minus our k value. So we're going to have minus a negative 2. Minus a negative 2 will become a plus 2. So minus a negative 2, you have y plus 2 squared. And then our radius is 3. 3 squared means 3 times 3, which is 9. So this would be the equation that would correspond to that center and that radius. So the key things to note. Notice over on the right, that number is our radius squared. So if you wanted to find what the radius was, you'd do the reverse of squaring, which is the square root. The other thing to note is in our parentheses here, notice because there's a minus in the formula, the center ends up as the opposite signs. So if we went in the reverse, let's say I had x plus 6 squared plus y minus 3 squared is equal to 16. Again, note our center is the opposite signs of what's in the parentheses. So our center in this case would be negative 6, positive 3. And 16 is our radius squared. So if we took the square root of that, 4 times 4 is 16. So our radius is just 4. So that's the main idea of what we're going to be working with today. And if we go down to the bottom, we'll practice that a bit. So our general center radius form of a circle. We'll have x, we'll have y. In our parentheses, it should be the opposite signs of our center. So we have 3 5s, we'll have x minus 3 and x minus 5. And then over on the right, it'll be equal to the radius squared. Well, 6 times 6 gives us 36. And that's it. That's your center radius form of the circle. In this next one, we'll start out again. We'll have an x part squared plus a y part squared equals our radius squared. Well, here we'll have an x, here we'll have a y. It's always the opposite signs. So we're going to have a plus 8. Now 0 doesn't have a sign, so you can either put in plus 0 or minus 0, it doesn't matter. And then when you square a square root, this is saying square root of 5 times square root of 5. We saw in our special right triangles unit that a square root multiplied by itself is just the number underneath. So square root of 5 times square root of 5 is 5. And the reason for that is squaring and square roots are opposites of each other. Now, what we have here in B would be correct in a free response question. But that's not how they would have it written if it was a multiple choice. If it was a multiple choice question, they'd have the answer as x plus 8 squared. But then for that second part, because y minus 0 is just y, they would write it as y squared and then equals 5. So in purple is how you would have to recognize it if it's a multiple choice, that by being y squared, it's really saying that it's y minus 0 or y plus 0 there. All right, and then the third example, so we'll have our x part squared plus our y part squared, and then we'll have our radius squared. So here's the x, here's the y. And for the center, we'll have the opposite signs of what our center is. So we'll have plus 2 and minus 1. The tricky one in this one is the radius. We need to do the radius squared. Well, that means we need to do the entire 3 square root of 2 squared. That's the same as saying 3 square root of 2 times another 3 square root of 2. It's been a while since we've seen things like this, but when you multiply your radicals, you multiply the parts out front together, and then multiply the radical parts together. 3 times 3 will give us 9. Up above, we had seen that square root of 5 times square root of 5 is just 5. So now if we do square root of 2 times square root of 2, that should give us just 2. And then we just have to multiply the 9 and 2 together to give us 18. You could also just do it in your calculator if you wanted, but you'd have to make sure to put the entire 3 square root of 2 in parentheses and raise it to the second. So we're going to look at some other variations of circle questions. So we're going to write an equation in center radius form, so the form we've been working with. We know our center, and we know a point that it passes through. So let's start out with what we know so far. We've got our x part squared plus our y part squared. Our x will have the opposite sign of the x part of our center, so we'll have x minus 5. For the y, we'll have the opposite sign of the y part of our center, so minus 8. But they don't tell us anything about the radius. We do know a point that passes through the circle, so let's just call that r squared for right now. If you have a point that is on the graph of any type of line, circle, parabola, whatever you have, if you sub it into its equation, it should come back with a true statement. So because the circle's passing through negative 15, negative 13, that means if we sub those in for x and y, it should come back with a true statement. Knowing that, it will allow us to find what r squared is. So what we're going to do is instead of having x, we'll put in the negative 15. Instead of having y, we'll put in the negative 13. And we'll leave it equal to r squared. And we can type in the left side and see what we get in our calculator. So take a moment right now, see if you can type in that left side exactly as it looks, and see what you get back. So when we type that in, we should have gotten 841 equals r squared. So we can now finish our equation. we know we had the x minus 5 squared plus y minus 8 squared. And the circle equation is always equal to r squared. So we don't want to even bother doing the square root, because that just directly tells us what should go here. It's whatever the r squared is. All right, we were given an equation in center radius form. We're going to find the center and the radius, and then we'll graph the circle. So to start out, our center is the opposite signs of what's in the parenthesis there. So we'll have positive 2 and positive 3. And our radius is the square root of what's on the right, because that 36 is the radius squared. So we need to think what number times itself gives us 36. And if you're not sure, just start climbing the ladder. 2 times 2 gives us 4. Nope. 3 times 3 gives us 9. Still too small. 4 times 4 gives us 16. Getting closer. 5 times 5 is 25. All right, getting pretty close. 6 times 6 is 36. Okay, that means our radius is 36, or is 6. Because 6 times 6 is 36. Often they will be nice numbers. If not, it would just be square root of whatever you see there on the right. Now when we go to plot these, we'll plot the center 2, 3, and the radius is 6. So we're going to go out 6 in 4 directions, up, down, left, and right. So plot 4 points, 6 up from our center, which would be right here, 6 down from our center, which would be there, and do 6 to the left and 6 to the right. Once you've done that, you want to get out your compass. So with your compass, put your point on the center, put your pencil on one of the points we know the circle passes through, and just make a full circle. Now it looks like mine was off slightly because it missed those points just a little bit, but it should be reasonably close. Okay, so when you do that, because I think there will be one on the homework like that, make sure to use your compass. Don't just freehand the circle. All right, for this one, same idea. Center is the opposite signs of what's in the parentheses, so minus 4, positive 1. For our radius, 4 times 4 is 16, 5 times 5 is 25, so that's not going to be a perfect square. So in our calculator, we can do square root of 23 to see what that gives us. And that is approximately 4.8. So we'll use that to help us graph it. We've got negative 4, positive 1 is our center, and we're going to go out 4.8 in each direction. There's about 4.8, 1, 2, 3, 4, and then 0.8. 1, 2, 3, 4, and then 0.8. 1, 2, 3, 4, and then 0.8. Once you have that, we'll go back to the compass. Put your point on the center again. Put your pencil on our points on the circle and draw in your circle. And again, it's tough on the smartboard. Hopefully it's a little easier for yours. It should be a little bit better going through those points. All right, next one. If you make a call on a cell phone, the cell phone tower receives the call. The circles and the points on the graph are representing the locations of the cell phone towers. Cell phone tower A, we want to describe the range of it. The circle is representing basically within that circle, the tower will pick up your cell phone when you try to make the call. So from A, we want to write a circle equation to represent the range. So we just need to think about what the center and the radius are. Well, our x value of this center is 16, and the y value of that center is 10. Notice our scale is going by 2's. So our radius, when we go from here to here, is just 10. Now, circle A is showing something called being tangent to the x-axis. We may see that in future questions, but being tangent to something means you just barely hit it at one point. Sometimes they describe that in circle equations. Instead of saying the radius, they'll say the circle's tangent to the x-axis, and you know it's just going down as far as it takes to get to the x-axis, and that helps you identify the radius. So you could see that at some point. So we've got our center and our radius. So we'll have the opposite signs in our parentheses. So x minus 16 squared plus y minus 10 squared. And then our radius squared, we'll have to do 10 squared, which is just 100. And that's an equation that represents the range that will pick up, that tower A will pick up any cell phone signals. All right, going to our last page, 28. We'll practice a couple of these today, and then we will see some more of them tomorrow before we take the quiz. Our equation here is given in what's called standard form of a circle. What we've been working with up to this point is center radius form. Center radius form is nice because it makes it easy to pick out, like the name implies, the center and the radius. So we usually like to convert to that. In order to convert to that, we have to complete the square. So we're going to take you through that process. It's usually challenging at first, but once you get the hang of it, it's not too bad. So the first thing we want to do is move any constants over to the other side. So we're going to subtract the 4 over to the other side, and that'll give us x squared plus y squared plus 14x minus 12y equals negative 4. Constants are things that don't have any variables with them. Next, we're going to group the x and y things together. So we're going to write x squared plus 14x. But we're going to end up putting something after the 14x. So we're going to put plus and leave a blank. And then we'll do the y stuff. So we'll do plus y squared minus 12y. And we're going to want to leave a blank for the y's as well. So we'll do plus and leave a blank, and then we'll have our negative 4. To complete the square, you always do your b value divided by 2 squared. Well, you might be asking, what is your b value? Well, last year in algebra, you should have done a quadratic formula, and you did some identifying of what the a, b, and c were to do quadratic formula. In a general quadratic setup, we have ax squared plus bx plus c. So the b is the part that's in front of the plain old x, or in the plain old y in our second part. So that's how you pick out where the b is, the part in front of the plain old x or the plain old y. So for the x's, our b will be 14. So we're going to have 14 divided by 2 squared. Well, 14 divided by 2 is 7. So we're going to end up doing 7 squared. 7 squared is just 49. So we'll put that in the blank. But you can't just add a 49 to a side of an equation. That unbalances the equation. So to keep it balanced, we need to also add 49 over on the right side. Now we'll do a similar thing for the y's. We need to do our b value, which in this case is negative 12 because it's in front of the plain old y, divided by 2, and then we'll square it. So that's going to give us negative 6 squared. If you were going to do that in the calculator, make sure you're doing it exactly how I have it written there. Negative 6 in parentheses, and then the squared. Negative 6 times negative 6 gives us a positive 36. So that'll go in our blank there. We need to keep it balanced, so we'll add 36 to the other side. So we're getting pretty close to being in center radius form. We can just add up what is on the right side there. Negative 4 plus 49 plus 36 is just going to give us 81. In center radius form, we know we need an x part squared plus a y part squared. So we'll put in our x and our y, but what should go with them? You will always put in with them whatever we squared to get the blank. So in the blue one, we squared 7, so we'll put in plus 7. In the green one, we squared negative 6, so we'll have minus 6. And now we are in our center radius form. The question asked us to find the center and the radius, so we can now identify that like we've done in the other questions. Center's the opposite signs of what's in the parentheses, so negative 7 and positive 6. And our radius is just the square root of what we're equal to. So we need to think what number times itself gives us 81, and that would just be 9. All right, we'll try one more of these. So we're going to put it in center radius form. It's currently in standard form. We'll need to complete the square. So we'll start out, add our constant over to the other side. Now, as I rewrite this, I'm going to already go ahead and group the x's and the y's together. And then we've got our 64 over on the other side. So that saves you a step. Instead of just rewriting it all mixed up, write it in the order that we want it. So we're going to do b over 2 in parentheses squared. B is in front of the plain old x or the plain old y. So we're going to have 8 over 2 squared, which is the same as saying 4 squared. 4 squared is 16. So we'll So b over 2 squared, we'll have 8 over 2 squared in this case. 8 divided by 2 is 4, so 4 squared gives us 16. We need to balance it off on the other side, so we'll add 16 as well. Well, let's do it for the y's. Our b is negative 2, so we'll have negative 2 over 2 squared. That's really negative 1 squared. Negative 1 times negative 1 is 1. So we'll add 1 there, add 1 to the other side. So we're going to have an x part squared plus a y part squared equals 81 when we add those all up. Just coincidence that it was 81 again will not always be 81. So what do we put with the x and the y? Whatever we squared. We squared 4, so this one will be plus 4. Here we squared negative 1, so this one will be minus 1. Our center is the opposite signs of what's in the parentheses. So negative 4, positive 1. Our radius is the square root of what we're equal to, so that's just 9 again. That's it for this video. Make sure to be doing your homework and studying for the quiz.